Alright, welcome to week 2 review for CS159. I'm going to be going over some fundamental concepts that you absolutely need to know for this course. So let's start by taking a closer look at the different primitive types we have in Java. We have 8 of them in total: byte, short, int, long, float, double, boolean, and char. On the right, you can see how we would write out a literal of that type. A literal is a value that you write directly into your code. It's just like a number. So in this table, the first 4 types we have are all designed for storing integer values, aka whole numbers. And we see that each type has a different size it takes up in a computer's memory. Byte is the smallest and long is the largest. And you can see how that influences the range of possible values. Down below, we have 2 floating point types that can store decimal numbers. These are float and double. And again, the larger double type can hold a wider range of values. So for floating point numbers, the size of the type also determines the precision. If you look at the example, you can see the double is able to store many more digits of pi. Now these types matter for what we'll talk about next, but you really only need to remember these 4 here. Use int for integers and double for decimals. This is different from Python. In Java, use double, not float. So why does the size and the precision matter? First, remember that variables can only hold one type of value. In that case, what happens when we try to assign a value with a different type? So say I had these 2 statements here. What would happen? Would this work, or would Java throw an error? If you ran this, you would find out that this is fine. So Java allows this. Why is that? A long can fit an int value because a long is bigger. But what about putting a long in a float? If we look at the table, a float looks like it's smaller than a long, but take a look at the range. A long can store numbers up to 10 to the power of 18. That's a number with 19 digits. But a float can store numbers up to 10 to the power of 38, a much wider range. So Java is actually able to do this conversion too. It's not just about the size, it's about how wide the range is. So the general rule is, you can assign values into a variable of equal or wider type. And these are in order like so. Byte is the narrowest and double is the widest. But what if you wanted to go the other way? Say you had a double with cups of liquid, a decimal number, and you wanted to put that in an int variable. This is not allowed because there would be a loss of information. An int can't store the decimal part. This could be a mistake. So we have to tell Java to pour out or truncate the extra information that wouldn't fit. And we do so by casting, using the syntax here. We put parentheses before the value we want to convert, and inside we put the desired type. In this way, we tell Java explicitly that we want to do the conversion, and it's happy with it. Now that we've covered types, let's take a look at the different operators we have in Java. We have our basic arithmetic operators. These take in 2 inputs called operands, and these operators let us form expressions that result in a value. They work how you would expect, like in math, but you have to watch out, because the types of your operands matter. Let's take a look at some examples. First of all, if you add 5 plus 8, which are both ints, you would get 13 as a result, which is also an int. But if you added 5 plus 8.0, you would still get the result 13, except that it's double. 2 times 3 would give you the int 6, but 2.0 times 3 would give you the double 6.0 as a result. See the pattern here? Let's take a look at division now, which can be tricky. So 10 divided by 4 actually gives you the int result 2. Why is the answer 2? Because if you divide 2 integers in Java, it performs what's called integer division. You get the result of 2 because 4 can only go into 10 a total of 2 whole times. Now, if you wanted a decimal result, then one of those operands needs to be a floating point number. So we can see a few general rules when working with operators. If both operands, again, those are the inputs, are the same type, the result will be the same type. If at least one is a double, then the result will be a double too. Now let's take a closer look at the modulo operator, which is that percent sign. The modulo gives us the remainder of a division operation. So 17 mod 10 results in 7 left over. And 4 mod 2 gives us 0 since there is no leftover. To help us remember, let's consider 25 divided by 6. 6 can go into 25 4 times. And then we get a leftover of 1. This is the remainder. And at the top, we have the quotient. So the different parts of division are reflected in Java a few ways. If we're doing floating point division, we get the full decimal result. If we're performing integer division, we get just the quotient. And then the modulo gives us the remainder. Modulo is super useful for determining divisibility. For instance, if you want to check if a number x is even, you can just compare if x mod 2 is equal to 0. To check if x is odd, just compare if x mod 2 has a remainder of 1. Or if x is evenly divisible by 5, then x mod 5 should be 0. With these different operators, Java puts them into different groups and evaluates them from highest precedence to lowest precedence. For each one of these groups, an expression is then evaluated from left to right to determine the order of operations. Now, what do I mean by this? Let's take a look at an example. What is the value of this expression? We start with the highest group and we scan the expression from left to right. Are there any parentheses? Yes. So we evaluate that part first and get 3. Since there is no more parentheses, we move on and look for operators in the next group. Since there is no logical knots, let's look for multiplication and division operators. Going in the expression from left to right, we see the first multiplication is 5 times 2. Then the next one is 10 divided by 3. And then 5.0 times 3. Now we move to the next group and repeat. So 6 plus 3 is 9. And 9 minus 15.0 gives us a final answer of negative 6.0. Make sure you pay close attention to the order of operations and especially the types. Do them step by step so you don't get the wrong answer. In case you need to perform advanced math operations, you can rely on Java's built-in math class. Here are some of the most important static methods you need to know. Math.abs will give you an absolute value. Math.pow will let you compute exponentiation. Now, as a reminder, Java does not have a star operator, so you must use math.pow if you have a power like this. There's math.random, which gives you a random double, math.sqrt for square roots, math.round, which is super useful to round decimal numbers to integers, and then math.pi, which isn't a method, so you don't call it, but it is a constant, which is like a variable, but the value can't change. You can use math.pi in expressions to help you compute things like the area of a circle. So here's something to remember. You need to call each method using its class name. So something like this, where I just call abs, doesn't work. You need to precede it with math dot. So math.abs in this example. Okay, let's talk about comparisons. Java has all your typical comparisons, equals, not equals, etc. These are binary operators, so they also take in 2 inputs. And the result of these comparisons is a Boolean value, a true or a false. They work like you'd expect, but here is a warning. Use caution when comparing floating point numbers. You may be tempted to do something like this, but Java will tell you that this expression is false. 0.1 times 3 is not equal to 0.3. In fact, 0.1 times 3 is equal to 0.30000000000000004, obviously. This is due to something called floating point imprecision. So if you wanted to compare the equality of two doubles, you'd have to do something like this. Basically, you have to see if the difference between the two numbers is sufficiently small within some allowed error. If you're writing JUnit tests and you use assert equals, you should provide a third argument, which specifies this tolerance. Tricky, right? But you've got to remember this so that you don't introduce bugs in your code. Java also has logical operators, not, and or. These are Boolean operators, so they let us compare Boolean values. Not means negation. It's a unary operator, so it gives you the opposite of what you specify. So if you have a variable a, if a is true, then not a will result in false. And the not operator is the little exclamation mark right there. A uses the two ampersands, and how it works is it results in true if all the inputs are true. So I remember by looking at the a in and. The a stands for all. And then we have or, which uses the two pipe or line symbols. Or is true if one or more of its inputs are true. The O stands for 1. And using these comparisons and logical operators, we can run code based on if a condition is true. The if statement lets us run some code only if an expression results in true. You can add an else to say, otherwise, do this instead. You can also introduce an else if, which is an additional check. Basically, if the first expression was false, check again with this next expression. You can add multiple else ifs in the middle, but you must have an if at the top, and if you have an else, it must be at the bottom. Now keep in mind that in Java, the expressions are in parentheses, the code to run is in curly braces, and else if is spelled out, not elif. And last but not least, we have while loops, which let us repeat a segment of code while a condition is true. For example, if I had this loop here, it would run while a is less than 5. So we would get the output of high printed 5 times. We also have the do while loop, where you run the code first, then repeat while the condition is true. This one has the advantage where we're guaranteed to run the code at least once, even if the condition is false. So in this example, we get the output of 0, even though we don't loop through again. That's it for this review, and I hope it was helpful. Also, don't forget to let your instructors know if you have any questions.